Hello! I didn't realise I started the video recorder. I ain't even going to leave that bit out. I shall include that. Right, I'm just going to make... Right, back. Wasn't the curry burning, it was the rice burning over. Boiling over, sorry. Anyway, so if you want reliability... don't know what that was. Right, if you want reliability, HKC. The other system I use is called Orisec. Orisec is a break-off company of a break-off company, and what they've done is they've built their alarm panels up from scratch. Very similar, they do similar stuff to HKC. Their app is free. I don't charge for the app. I don't maintain the app. I do have connection to it, but for me to be able to get into it, because of data protection, etc, etc, I put my credentials in the customers panel so that they can get me in if they need to. I can't get in on my own because I don't give myself that right to do that. But they can easily get me in through talking to me on the phone, and I can tell them what to do at their end. Have I had any issues with them? I have had a little bit of an issue, and when I say an issue, it's minute. They have a problem, or had a problem, with their remote keypads, in that they were going off into tamper because of the design of the keypad. Now, I do know that Orisec are proactive, and to be honest, that is not worried me in the slightest. They do have a lot more equipment out there than you will get with HKC, because HKC is predominantly radio, where Orisec is right. They look forward to, they've gone forward and things. If I could get a drink. Oh, blimey. The wife's gone out. I've gone to see Jasper Carrot with a mate. So I've just dropped him off. I've come back and I thought, oh, I'll have this video because I've got these 3 text messages, etc. So I thought I'll approach this. Anyway, I am going off the subject, but I'm just telling you what I like, as in alarm equipment. So Orisec, they do a lot of stuff. It's too much for me to go into. They do seismic impacts. They do stationary impacts, where if you're doing an alarm system on give you an example, a museum, and there's a painting, you can stick this device on the back of the painting, and once the system is set, like the system in a museum, the system would always be set in some tier or level. But let's say, for instance, you put it on proximity, so you've set it for proximity detection only, which includes the seismic and stationary stuff. If you move the picture that this device is on, move it from A to B, without vibration, it will still go off. It works on the same system as your mobile phone, using the Earth's magnetic field. It's got like little cross, very, very fine cross hairs, resistors, and it does a lot of maths, and it can find out where it is and how much it's moved, etc. And this is what these do, that you move, it produces a voltage, it calculates where it is geostationary or whatever, and it says that something's gone missing or something's been moved. So if you wanted to put it on your tools in your van, you come home, you put it on the tools in your van, obviously it'll be stuck there all the time because you don't want it coming on and off. Once you set the alarm, if them tools move, it'll pick up on the alarm. It doesn't have to be shook, it just has to be moved from A to B. It's not a contact or anything, it's not a vibration centre. It's like a geo, what's it, what's that down where I'm after? It's an H thing. Anyway, right, the question was that people have asked me, and they both asked me the same question, so I don't know if they're from, and it happened within 2 days, so I don't know if they're related, but they've both asked the same question. Alarm systems, and what they've come to do is they come to change an old alarm system that's in situ and put a new type panel. Well, a lot of the panels now are in 50131. A lot of them are what we call end-of-line resistors or ELO or, you know, 2-wire, put it like that. Where the old BS4737 systems and some of the early 50131 systems were 4-wire. So you get a wire coming out of your alarm panel all the way around the detection loop and back, and that would be a tamper. You would get another set of wires, so it's 2 pair there, another set of wires going through the contact or the detector, and if that goes open circuit, the alarm panel knows. So you've got this other zone coming out and back down. So you've got 4 wires. A lot of the alarm systems now only come with 2 terminals. So you've got it in and then out. And the way you get those to work is you balance resistors to do it. And different manufacturers use different balances on the resistors. So I'm going to get my pad out. I'm going to try and get this camera so it's facing down because I'm going to be doing a bit of hard work. Hang on a bit. I'll say that again. Hard work. Right. Yeah, and see if you can follow me from that. Okay, I'm going to turn this round, check my curry again, and I'll be back. Now, like I said, it's going to be very basic. So here's a PIR, passive infrared. Here's your alarm. Okay, so let's say there's 10 zones on this alarm. And what you'll find is there'll be so many inputs. I've just had a slurp of my my whiskey and a spoonful of my curry. So there's more circuits than this on a PIR, but for the sake of it, let's say for instance that's the alarm loop. Now don't forget this is a takeover situation where there's got old detectors in and a new panel, and that is your tamper. If you did it with new detectors, it would be a lot easier. So you usually get 1, 2 and a common, 3 common, 4, etc. So there is zone 1 and 2 with a common wire. So what we would do is we come out of zone 1 into the tamper. So The tamper's a push button like so. So if you push the button, it makes a short circuit. Here, coming out, you would need to put a resistor. And I'll go into the values. Then you would come into the detector. You would need to put another resistor across the detector and then back. I hope I'm making this clear enough. Back to common. So imagine it like water. Water would go up this zone, up this wire, through the tamper because the tamper's made, through the resistor, over onto the alarm side. Now, if the alarm circuit is, let's say for instance, closed circuit, which means nobody walking around, it would short out that resistor. It would short out that resistor and then allow the water to flow back down and across. Okay, so I think you've probably got that. If you ain't, put some more comments down, put them on YouTube rather than leaving text messages, because I'm a devil for text messages. I'm going to be honest, I'm dyslexic, so I hate text messages. I'm also colourblind for an electrician as well, but never mind. Right, so I'm going to expand on that one because we know these come out of here. So let's turn the page. Let's make sure there ain't nothing on this page that's going to... No, okay. So let's expand this detector. Here it is. Big detector. So there's two. There's more than this, but for the sake of it, we got a normally open and a normally closed. That's your tamper switch. Right, so you've got your cables going up here into there. Right, here, if we put a resistor, let's say for instance, 2, we call it 2 ohms. It's a lot more than that. It's usually about 2K, 4K, 2.2K, whatever. That goes into that. So this resistor is physically wired across to that zone. So that's your alarm zone, alarm side, and that's your tamper. Here, there needs to be another resistor, and this is called a shunt resistor. Right. And it comes back down, all the way back to the panel. So let's see what happens. Let's say for instance, this is 2. Now, for the sake of it, we can see that that's open, which means the PIR, passive infrared, is picking up movement. So if it's picking up movement, let's see what the value of the resistor is. We're going to say 2, but if I say 2000, that's going to be okay. So all the electric goes up through the tamper switch into that resistor. Now, instantly it's added 2000 ohms onto that circuit. So with the detector open circuit, it's not shorted across, it's adding another 2000 ohms that come back to there. So the return resistance across there, those 2 points, is 4000 ohms. Right, so here's the next scenario. If the detector is what we call closed circuit, and there's no one walking about, this is what we see. Put the detector in here again. I'm deliberately making big, so I mean I've got enough lines on that paper anyway. Flipping heck. Here's my two. So here's your tamper switch. Here's the cable going up. Here's a resistor across, which is 2K. Goes into there. This time there's nobody walking around, so that switch is across. Here's the resistor, which is a shunt resistor. And then this comes all the way back to the panel. So let's follow it this time. Another slab. Right, so power goes up to there. Tamper switch is made because the cover's on the detector. It goes into this resistor and it instantly sees 2000 ohms. It comes out of the resistor and then it goes across an infinite resistive load, which is short circuit. So it goes across there. It doesn't see that resistor because that's shorted out by that switch now. So it then goes back down to the alarm panel, and the measurement across these 2 points here in the alarm panel is 2000 ohms, or 2000 ohms. So this panel is designed, or the programming that you set it to is designed that if you see 4000 ohms, it'll go off into alarm. Let's bring that page back. Right, let's get this back in focus. Right, so this is a detector that's picking up something. It's open circuit up here. So it's coming across here, through the tamper switch. 2000 ohms it sees there, comes into that point there for the micro switch. It can't go across there because it's picking up movement, so it's going through the resistor. It's adding another 2000 ohms coming back down here, so the panel now sees 4000 ohms, and that would be an alarm state, and the panel would know that because of that resistive load. Back to this one. Let's get it in focus because I'm looking at the page, not the camera. Right, power goes up. PIR, passive infrared. This is closed circuit, so there's picking up no movement. It goes through there, through the tamper switch, because the tamper switch covers on. It goes into a resistor. It adds 2000 ohms. It comes into the alarm side of the micro switch. Now, because it's closed circuit, there's picking up no movement, that switch is closed. So it can't see that resistor there, 2000 ohms. So it bypasses and sees 0 ohms. So it adds 0 ohms onto 2000 ohms and carries it through all the way back to the alarm side. So at the alarm side, you get this scenario, 2000 ohms, 2000 ohms, I just K means 1000. So that means that that is closed circuit, which means it's okay. Right, now let's have a look what happens if somebody takes the lid off this detector. So I've got to be honest, if they're playing with the lid, let's go on to this one. If they're playing with the lid, it's going to be picking them up anyway. But this is in the daytime when the system's off, so it needs protection on that device. So nobody can come in and put a bit of cotton wool in, so the detector won't work, it won't see anybody. So let's have a look here. So power goes up into the first terminal of the micro switch for the tamper. Now, if the lid was took off, that button would be pushed down here, and you would get an open circuit which the power couldn't flow across. So now it's seen infinite resistance. So power can't go into there, can't go down there, can't bypass one of these, can't come and can't return to this point. So it now knows that if it's got infinite resistance, give me symbols, that's going to go off into tamper. So that would be into tamper. And that's all it is to the alarms. Easy. Any questions? Just pop me a comment, ask me the questions. There is different values to these because it does depend on what panel you fit in them. On the newer panels, you will find that these can be anything, and you can tell the panel what it is. But you usually get, let's go over to this one. Normal configurations is 2K2 and 4K7. So ohms. So what that means is that means 2,200 ohms, and these are usually about 10%. That's 4,700 ohms. So you can see that when that goes into an alarm, what it will say is, on this one, you add them together because it's in series. So you got 6K9. So in alarm, it's in 6,900 K ohms. Anyway, that's all. GTFM.